we talk about what is a function. We talk about what it means by taking limits of a function, and we talk about what it means by function f is continuous at a point or for an arbitrary values. We move on to our next concept, which is about differentiation. Okay, so when I have a function f of x, suppose this function f is nice and smooth, doesn't have weird behavior, then we can do this action. Okay, we can do this to the function f. So we'll do the difference equation, and we take the limit, let h approaches 0. And after h approaches 0, we get a value that depends on the number x. So the outcome here is another function of x, and the f prime here in the box is just the name. So this is basically the same as, say, I have g of x, but I don't want to use g or h or other names. I want to write it as f prime because it's like a child of the function f. Okay, so we write it as f prime. And this formula looks a little tedious. We're gonna see examples, but for now, just don't worry about it. Just write down the definition. This is how the derivative of a function is being defined. And if this limit exists, then you say f is differentiable. Okay? And next, I want to talk about a little bit of notation convention, because we need to know how to write, and we need to know when we say certain sentences, what does that mean, okay? So if I have a function, I can say just a function f. I can also say, oh, this is function y equal to f of x. That's like general setting. We have all seen a format like this here and there before, right? So the derivative of this function can be written as, like I have up here, say that's f prime of x. And because f and y are basically the same, so if I want to, I can also say this is called y prime of x. Okay, and we can also have another expression like dy over dx, but this whole thing is like one piece of notation. It's not like division. It's not like you have the dy divided by dx. No, this is like a one piece. So have you seen those kind of like clothes that looks like a two pieces dress, but they're actually connected? That's one piece. You cannot separate them. So this is like they're kind of like fake two pieces dress. Okay, so this is one piece. You do not separate the dy and dx. When you want to use this notation, you always write this dy over dx all together and treat this as one thing. Okay. The second thing that I want to point out is the action here. You know, taking the limit of difference quotient is said as differentiate a function f. Okay, so differentiate is a verb, so I can say ddx. This is the verb, means differentiate. Now you have a verb acting on a function, so differentiate this function. Okay, so then the outcome of this action is you get the derivative of y. So now I can say this is dy dx, okay? Or you can say this is f prime of x, or you can say this is y prime of x, okay? So all this three symbols here, they refer to the function, the outcome of the action, the outcome of the action, which action? The action taking the limit of difference quotient, okay? So this is the outcome, and this outcome is so-called the derivative, okay? Derivative of f over derivative of y equal to f of x, if you want to be a little bit more precise, okay? So from now on, when I say I differentiate a function, that means I'm looking for the derivative of the function. Then I should go ahead and use this process. Or later we're gonna learn a bunch of derivative formulas, and then we can apply the formulas to find derivatives. Or I can say find the derivative, okay? Differentiate y is the same as saying find the derivative of y, okay? Differentiate y is the same as find the derivative of y. Different ways of saying it, but it means the same thing, okay? Just the notation convention and the writing part.